In this video, we're going to talk about how to simplify expressions with rational exponents. So rational exponent is an exponent that's a fraction, and it can be rewritten as a radical using this property. X to the m over n equals the nth root of x to the m. We can also rewrite this as the nth root of x raised to the m power, because we can do these exponents in any order. So that basically is telling us that the numerator of this fraction tells us the power, and the denominator of this fraction tells us the index. When m is 1, this property can be rewritten as x to the 1 over n equals the nth root of x. And you'll see this used a lot. Like, for example, if you have x to the 1/2, you're going to be able to realize that that's just the same thing as the square root of x. So we're also going to be using these properties of exponents when we work on simplifying these, especially when we're trying to get them in radical form and other things like that. The product of powers property and the power of a power property are going to be very important to us as we work through these problems. So let's rewrite 2 to the 1/6 cubed as a radical. So the first thing I can do here is realize that I have a power to a power, and remember that tells me that I can multiply those exponents. So I'm going to take this 2 to the 1/6 to the third and multiply that 1/6 times 3. So remember, that's like 1 over 6 times 3 over 1. So I can reduce these before multiplying, right? Because 3 goes into 6 2 times. So that's just going to basically turn into 2 to the 1/2. Well, 2 to the 1/2, if I use that property, that's going to turn into the square root of 2 to the 1. Right? But I usually don't write that 2 for square roots, and I usually don't write exponents of 1, so I can just rewrite this as the square root of 2. So when we simplify expressions with rational exponents, we're going to rewrite as a radical using that property. Then we're going to simplify the radical whenever possible. So let's rewrite this as a radical. So we have 15 to the 2/3. So remember that numerator is going to become my power, and denominator is going to become the index. So this is the cube root of 15 squared, but I don't want to leave it like 15 squared in my problem, so I'm going to turn this into the cube root of 225. Okay, there's no perfect cubes that will evenly factor 225, so I'm just going to leave it. So now let's try rewriting this using a rational exponent. So I have a radical in this problem, but remember that power tells me the numerator and the index tells me the denominator. So that part on the inside, I can rewrite that as 7 to the 2/3, and then all of that is being raised to the 1/2 power. Well, I have a power to a power again, so I can actually multiply those exponents. So if I do 2 over 3 times 1/2, well, that 2 and 2 will cancel, leaving me with just 1/3. So this whole thing just simplifies to 7 to the 1/3, and we can leave that since it's asking for a rational exponent. If you want to know, it's as a radical, it's just going to be the cube root of 7. So now you can go ahead and pause the video and try doing this example on your own. So here we have a radical, and so the numerator is going to be the power, and the denominator is going to be the index. So we have 5 to the 2/3, and that's how we rewrite using a rational exponent. So let's go ahead now and simplify this. So whenever I'm trying to simplify expressions and I have a rational exponent, I like to rewrite it as a radical because it helps me see what I'm working with. So if I rewrite this, I have the cube root of 64 squared. Well, I want to be a little bit strategic here because if I square 64 and try to find perfect cubes that factor 64 to try to simplify, that's going to be a lot of work. So I'm going to rearrange this a little, and I'm going to do this as the cube root of 64 squared, okay? I'm just doing the exponents basically in a different order. So this is going to be easier for me to work with because I know that the cube root of 64 is 4, right? So this is basically 4 squared, which equals 16. So you see, rearranging it sometimes can get a little bit easier for you to simplify. So let's try now this example. So I know we did problems like this when we were talking about nth roots, but I just want to show you how it can be easier to simplify using rational exponents. So for example, we can rewrite this as 64 to the z to the 6th to the 1/3 power. Okay, so now both of these terms are going to be raised to the 1/3 power. So I have 64 to the 1/3 and z to the 6th to the 1/3. So 64 to the 1/3, that's just the cube root of 64. So that's going to be 4. Z to the 6th to the 1/3, I can, multiply those exponents, right? So I have 6 times 1 over 3. 6 is basically 6 over 1, so I can reduce these two, and this is going to turn into 2. And that's just going to basically turn into 2 over 1, which I can just write as 2. So this final answer is going to be 4z squared. So now let's try simplifying this expression. So I'm going to take this 36x to the 4th, y to the 16th, and raise that to the 1/4 power. So if I separate this, I have 36 to the 1/4, and then I have x to the 4th to the 1/4, and I have y to the 16th to the 1/4. So 36 to the 1/4, well, it's not a fourth root, right? But I can rewrite 36 as 6 squared. Okay, so this is 6 squared to the 1/4 power. And then 4 to the 1/4, that's going to be x to the 4 times 1/4. And then y to the 16th is going to become y to the 16th times 1/4. So 6 squared to the 1/4, I'm going to multiply those exponents, and then 2 times a fourth is going to give me a half. So this is going to be 6 to the half. 4 times 1/4 is just going to be 1, so that's just x to the 1. And then 16 times 1/4 is going to be 4, so I have y to the 4th. Well, 6 to the 1/2 is going to turn into the square root of 6. So I have the square root of 6 times x, y to the 4th. So that is my fully simplified expression. So now you can go ahead and pause the video and try doing this example on your own. So we have the 4th root of 81x to the 8th. So this is 81x to the 8th to the 1/4. So that's 81 to the 1/4, and then x to the 8th to the 1/4. So 81 to the 1/4 is the 4th root of 81, which is 3. And then 8 times 1/4 gives me 2, so I have 3x squared as my final answer. So you can use the property x to the m over n equals the nth root of x to the m to rewrite and simplify expressions involving rational exponents. Remember to also use the properties of exponents whenever needed.